Bismillah, this is Dr. Magda Talib Al-Hinai from the Department of Mathematics and Statistics presenting systems of equations and their solutions. This presentation is exclusive for the Independent Learning Center at Sultan Qaboos University. We first start defining systems of equations being a set of equations that involve the same variables. When we say we want to find the solution of a system of equations, then we mean that we want to find the values of the variables which satisfy each equation of this system. So, solving a system of equations means finding all solutions of the system. Now we present two methods to solve systems of equations. The first, we solve equations by elimination. The second method, solving equations by substitution. Method 1, solving systems of two equations by elimination. We have a procedure to do that. We first choose one of the variables and make its coefficients equal in both equations. Then we subtract the two equations to eliminate that specific variable. And we solve the equation for the remaining variable. We get this value from step number 3 and we substitute it into one of the given equations to find the value of the variable 1. On this method, we see an example. The example says, use the method of elimination to solve the system of equations. And we have equation 1 to be 2x minus 3y equals 1, while equation 2 is 3x plus 4y equals 10. Now, to eliminate x, we multiply equation 1 by 3 and equation 2 by 2. So we get, for equation 1, we have 6x minus 9y equals 3. We call it equation 3. And for equation 2, after multiplying it by 2, we get 6x plus 8y equals 20. And we call this equation equation 4. Now we subtract 3 from 4, we arrive at 17y equals 17, meaning that y is equal to 1. Now substituting this value for y into equation 1, we get the value of x, which we eliminated it early. Accordingly, the solution of the given system of equation is 2 and 1. The second method of solving systems of two equations is using substitution. So there is also a procedure for this method. Step 1, we choose one equation to solve for one variable. Call it variable 1. And we solve for this variable in terms of the other variable, which we call it variable 2. Step 2, substitute the expression you found in the last step into the other equation. This gives an equation in one variable, which is variable 2. Now we solve for variable 2 and find its value. We substitute the value we got from step 3 back into one of the given equations to find variable. We have an example. Use the method of substitution to solve the system of equations. 3x minus 4y equals 46. 2x minus y equals 14. Now we use equation 2. We can bring y on one side and all the rest on the other side. So here we have y equals 2x minus 14. We call this equation equation 3. From equation 3, we substitute into equation 1 for y. So in 1, we remove the y and we replace it by 2x minus 14. So we have 3x minus 4 multiplied by 2x minus 14 equals 46. We open the bracket and we collect the similar terms together, so we get x equals to 2. Now substituting for x equals 2 into equation 3, we arrive at y equals minus 10. Accordingly, the solution of the given system of equations is 2 and minus 10. Another example. Solve the system of nonlinear equations. X squared plus y squared equals 100. This is equation 1. 3x minus y equals 10. This is equation 2. And as we all see, from 2 we can get y equal in terms of x, so y equals 3x minus 10. And we call this equation 3. From 3 into equation 1, substitute for y, we get x squared plus, instead of y squared, we put 3x minus 10 all squared equals 100. Now solving for x, we will get a quadratic equation in x. So this will give us two values for the variable x. So as we see that one of the variables is 0 and the other is 6. So when x equals 0, I substitute into equation 3. I have y is equal to 3 multiplied by 0 minus 10. So this tells us that y is equal to minus 10 when x is equal to 0. Or for x equals 6, again, I go back to equation 3. I remove the x and I put the 6, so I get y is equal to 3 multiplied by 6 minus 10. This is 18 minus 10, so gives us y is equal to 8. And accordingly, we can see that the given system of nonlinear equations has two solutions. The first is 0 and minus 10. The second is 6 and 8. Now, we have applications on systems of equations. We have two applications, one on market equilibrium, the other on break-even analysis. So we start with market equilibrium. We have the definitions, the law of demand, which is a relation that specifies the amounts of any commodity that consumers are willing to buy at different prices, while the law of supply is a relation that specifies the amounts of any commodity that suppliers are willing to make available in the market at different prices. And at market equilibrium, the supply function will be equal to the demand function. Example on market equilibrium: determine the equilibrium price P and quantity Q for the following demand and supply laws. P equals 25 minus 2Q. This we call it equation 1. And P equals 3Q plus 5. This we call it equation 2. So we have the supply and the demand, and we know that at market equilibrium, supply equals demand. So from equation 1 and equation 2, we can write 25 minus 2Q equals 3Q plus 5. Now solving for Q, we obtain the equilibrium quantity, which is 4. And substituting for this quantity into equation 1, we get the equilibrium price, which is 17. The second application is break-even analysis. We start with the definitions. The total cost is defined to be the sum of total variable cost and fixed cost, while the revenue function is given by multiplying the unit price by the quantity. The profit function is the difference between the revenue and the cost functions. Note that if the revenue is greater than cost, then the business is making a profit, while if the revenue is less than the cost, then the business is running a loss. And if the revenue is equal to the cost, then the business breaks even. No profit, no loss. Now we have an example on break-even analysis. A factory of Omani Halwa sells its boxes of halwa for 2 riyals each. If the production cost is given by C of Q is equal to 100 Q squared plus 1300 Q plus 1000, where Q is the number of weekly produced halwa boxes in thousands. Find the quantity needed to be produced so that the factory breaks even. Now we calculate the revenue. We know that the price of one box is 2 riyals and the quantity produced weekly is Q in thousands. So the revenue equals 2000 Q. In order for the business to break even, the revenue and the cost must be equal, meaning R of Q must be equal to C of Q. So from the above equations, which are given the numbers 1 and 2 in front of us, we can write that 100 Q squared plus 1000 Q plus 1000 is equal to 2000 Q. Dividing both sides by 100, we arrive at a quadratic equation in Q, which when factored, we get either Q equals 5 or Q equals 2. And again, these quantities are in thousands. So the company breaks even when it manufactures and sells 2,000 or 5,000 Omani Halwa boxes weekly.